Okay, question 8. We're looking again for the angle APC, this time a different position, APC. We're looking for this angle here. Okay, again, don't worry about how to work out the question as such, just start to fill in the diagram with as much information as you can find out. So just take it stage by stage. It might be that you find information that you don't need, but that's not a problem. Okay, first thing that strikes me is I've got lots of radii here. So we've got lots of isosceles triangles. I might be able to use some of that understanding. I'm interested in this triangle here, OD, OC, CD. And there's this line going through it, which is also a radius. Now, one of your circle theorems states that if you draw any chord, just like you have here, DC, and you take a radius from the center, it will cut it at 90 degrees and will cut it in half. It will bisect that line. Now, if it's bisecting the line, it must also be bisecting that angle. So we know that must be 59 degrees. So we've now got a little triangle here. We know that's 90 degrees. So, sorry, when I say the triangle, let me just make sure you're absolutely clear on the one I'm talking about. I've got a triangle here. I haven't got a letter here, so I've got a pink triangle here. It's clearly a right angled triangle. So I've got 59 degrees, 90 degrees. I should be able to find this angle now at C. So 180 degrees in a triangle. I've already used up 90. That leaves us another 90. We've used up 59. So that leaves us with 21 degrees. Okay. I'm already thinking to myself that maybe I've got a little triangle going on here, that maybe it's quite good to try and find that angle there, or possibly I could be looking for that angle there and use my opposite angle rules. So just trying to think ahead a little bit. Okay, the next thing I can see is I've got another isosceles triangle, which I'll identify this time with a green colour. OA, AB, BO. Okay, so we've got another isosceles because OA is a radius, OB is a radius, and we already know this angle here at O because we've got 81 plus 59, so that angle there must total 140 degrees. So that leaves us another 40 degrees to be evenly split between these two angles here. So they must of course be 20 degrees each. Now it looks like using my opposite angles might work better here, because if that's 90 degrees, that also must be 90 degrees. I've got a little right angled triangle here, it's only a small one. 20 degrees, 90 degrees. That means that little angle there must be 70 degrees. And using opposite angles, we know that the angle APC, which we're after, must also be 70 degrees.